sir. I am Vice Teacher Rita of CSC Department. Today my topic is about dynamic memory allocation functions with example. What is memory allocation? Memory allocation refers to the process of reserving a portion of computer memory for use by programs and processes. This is essential for the execution of applications as it allows them to store and retrieve data efficiently. There are two primary types of memory allocation: static memory allocation, dynamic memory allocation. Static memory allocation. Static memory allocation occurs during the compilation of a program. The memory required by the program is determined and allocated before execution begins. This method is efficient as it eliminates the need for memory allocation operations during runtime, leading to faster execution. However, it requires the memory size to be known beforehand, which can lead to memory wastage if the allocated size is larger than needed. Dynamic memory allocation. Dynamic memory allocation happens during the execution of a program. Memory is allocated as needed, allowing for flexibility and reducing memory wastage. This method is particularly useful for programs with variable memory requirements. Dynamic memory allocation process. The memory is divided into three: stack, heap, permanent storage. Permanent storage is used to store program code. Memory space stack used to allocate static memory allocations that are ordinary variables and arrays. Heap is used to allocate dynamic memory allocations. Dynamic memory allocation in C refers to the process of allocating memory during the program's runtime as opposed to static memory allocation, which occurs at compile time. This approach provides flexibility and efficient use of memory, especially when the size of data structures or memory requirements cannot be determined. The key concepts of dynamic memory allocation allows programs to request memory from the heap, a region of memory separate from the stack. Unlike stack memory, which is automatically managed and deallocated when a function exits, heap memory must be explicitly managed by the programmer. Functions like malloc, calloc, realloc, and free from the standard library .h library are used for this purpose. Memory allocation is divided into four types: malloc, calloc, realloc, and free alloc. Explanation of functions. Malloc size allocates a block of memory of the specified size and returns a pointer to the beginning of the block. The memory is uninitialized. Calloc allocates memory for an array of number elements, each of size, and initializes all bytes to 0. Realloc resizes the memory block pointed to by PTR to the new size. It may move the block to a new location if necessary. Free PTR deallocates the memory previously allocated by malloc, calloc, or realloc. The example program on dynamic memory allocation. Advantages of dynamic memory allocation. Flexibility. Memory can be allocated as needed during runtime, making it ideal for scenarios where the size of data structures is not known in advance. Efficient memory usage. Prevents wastage of memory by allocating only what is required. For example, instead of predefining a large array, memory can be allocated dynamically based on user input or program requirements. Dynamic data structures. Enables the creation of data structures like linked lists, trees, and graphs, which can grow or shrink as needed. Drawbacks of dynamic memory allocation. Dynamic memory allocation allows programs to request memory at runtime, offering flexibility for variable size data structures. However, this flexibility comes with notable downsides, especially in real-time or resource constrained environments. 1. Non-deterministic execution time. Allocation and deallocation times vary depending on heap state and fragmentation. Memory fragmentation. Frequent allocation and freeing of differently sized blocks can fragment the heap. Allocation failures in long-running systems. debugging complexity and security risk, memory related bugs. Important considerations: manual deallocation. Memory allocated dynamically must be explicitly freed using free program to avoid memory leaks. Fragmentation, excessive allocation and deallocation can lead to memory fragmentation. Error handling. Always check the return value of allocation functions malloc, calloc, realloc to ensure memory was successfully allocated. Thank you.